So let's start with this experiment. So the experiment aim is to determine the resistance of the galvanometer by half deflection method and also to find its figure of merit. Now the formula for resistance of galvanometer is given by G equal to Rs divided by R minus S, where R is the resistance taken out from the resistance box, S is the resistance taken out from the shunt. Now for the figure of merit, the formula is given by I is equal to K theta, where K is the figure of merit. So therefore K is nothing but I by theta, and we will replace I using Ohm's law. So K is equal to V by R plus G into theta. So here is the circuit diagram. Now I have connected the circuit diagram. So positive of the battery goes to positive of resistance box, negative of the resistance box is going to positive of galvanometer, and then negative of galvanometer is going back to the negative of the battery. Now here I have connected only this circuit, this part of the circuit. Now I have to complete the circuit by connecting shunt in parallel with the galvanometer. Now how to connect shunt parallel with the galvanometer? As you can see, positive of the shunt is going to positive of galvanometer, negative of shunt is going to key, and the other end of the key is going back to negative of the galvanometer. So that's what I have done here. Is you can see one wire goes from positive of galvanometer to the positive of shunt, negative of shunt is going to key, and the other end of the key is going back to negative of galvanometer. So I have connected shunt with parallel to galvanometer. Now I have to put the key. So this is the observation table for half deflection method. The first column is the resistance taken out from the resistance box. Next column is deflection, that is deflection observed in galvanometer. Third column is shunt, whatever the shunt resistance you take out from the shunt box, and G is given by Rs by R minus S, and K is given as before. Now procedure is important here. It says that the first step is to take out the key. So the first step is, of course, switch on the battery. Then you will observe full scale deflection. As you can see, I am observing full scale deflection in the galvanometer. Then you have to take the key out. So the key was here before, now I have taken that out. Now in that situation, you have to remove a resistance from the high resistance box, which is here. This is the high resistance box, this is the shunt. So I will remove a high resistance from the resistance box, maybe 5000 ohms. Now when I removed 5000 ohms, I have to remove such that the deflection is something even. As you can see, the deflection is 24. So I can write here that the resistance I have taken out is 5000 and the deflection observed is 24. Now the third step is very important. You have to plug in the key. Once you plug in the key, the deflection in the galvanometer goes back to 0. In such a situation, I have to remove some resistance from the shunt again, such that the deflection is half of what I observed earlier. So I'll take out 100, and as you can see, the deflection is around 12 now. Now before the deflection was 24, now the deflection is 12. Now what is the value of shunt? I have removed, as you can see, 100 ohms. So I'll write 100 here. For the 100 ohms, the deflection is 12. Now I'll calculate G and I'll calculate K. That is the end of the experiment. You have to do take 4 more observations by taking out different R values. Maybe you will take next 6200, maybe you will get some other deflection, even maybe 16, and then you repeat the whole thing over again. So let's do the calculation. So I have got resistance to be 5000 ohms, so I'll calculating G here. G is Rs divided by R minus S. So R is 5000 into S is 100, and R minus S divided by R minus S. R minus S is 5000 minus 100, which is 4900. So I am getting 102. So I'll write here 102. Now how to calculate K? K is nothing but V divided by R plus G into theta. V is nothing but the supply voltage, which is 2 volts here. So I'll write, first I'll calculate R plus G, as the formula says. R is 5000 plus G is 102. So I'll get 5102 into theta. So into theta as you can see is 24. So into 24 I get 1,22,448. So I have to do 2 divided by 1,22,448. So I'll do that, 2 divided by 1,22,448. So I have now got the value of K, figure of merit, which is nothing but 16 microamps. So I am getting 16 microamps per division. So the exact value you are supposed to get is written over here itself. You can see it's 20 microamps per division. So 16 microamps is acceptable.